Hello everyone. Today I'm going to show you how you can make a non-intrusive debug system. I'm also going to provide you a GitHub link to my code so you can just copy that into your project and start using it today. So what my code supports is an on-screen debugger, as you can see at the top left, that can be toggled by pressing F11. And in addition, we have this menu here with two functions. One, it has visibility groups where nodes can be added to groups and they can be shown or hidden. And I can call methods within my node. So here I'm toggling my spawners on, and I can toggle them off again by clicking the button. You can also see that this on-screen debug updates instantly when something is changing. So how does this work? And why do I call it non-intrusive? The reason I call it non-intrusive is because it's very, very easy to add stuff. And it doesn't really affect your game code. So let's start by adding these icons that are moving across the screen from the spawners to a visibility group. There are two ways I can do that. I can type VG underscore something like this, moving icon, and add it to this group. The VG underscore is a group I look for when the node is added, and if it's in that group, oops, I added it on the wrong node. Let's add it on the root node, like this. If it's in this node, my debug system will detect it, and it will display it as a visibility group. So if I go in game again, hit F12, you will now see that there's a visibility group for the moving icon. And everything that's spawned into this group is automatically hidden if it's toggled off. Alright, so you can see that the moving icons are actually being spawned on the left side here. If you look at the remote display on the left, you can see that they are still being spawned even though I'm hiding them. I had to hide all this stuff. The other way I could do this is I could go into the source code. Oops, here. Go to my moving icon, I can add a annotation. So debug visibility group, moving icon. I can also put it in multiple groups, so other group, for instance. And if I start my game, when this is added, it is also detected. So now you see we have a moving icon group and I have another group. And if either of them is toggled off, they will not be visible. All right. So that's the visibility. And if you look at the buttons, we can go here and look at the spawner. You can see I have this on-screen debug. This is up here. Any method or variable or property or member that returns something that can be toString can be displayed here. I simply add a category and add a name and a color, and it will be displayed. So I can change this to green, for instance. Oops, wrong button. We go back to Godot, we run it again. We'll see now this text is green. You see that the category is the name of the node, and then there's the text, and then there's the value of if it's spawning or not. I can also do more advanced stuff, so I can take this out, or actually I can leave it. Let's just leave it. I can go down here and I can write the method. String is spawning. It's called debug. Like this. I'll add this. Let's call it spawning method. Let's make it blue. But I want to color if it's spawning or not. So I will do is spawning. If it's spawning, I will return. So we can use the same tags that you can use inside the rich text box, because the on-screen debug is not rich text box you can use here. So I can use, if it's spawning, I can use green, and I can type true. So something like this. And then I can just copy this. And we can make it red and false. So if I go back in Godot now, start the game, you will see the spawners are set to true, that's green, the color of the text itself is blue, the color of the if it's spawning or not, and as I switch them, they turn to false. The old text is still there because I still have that annotation up here. Right? And finally, actions. You saw I have the toggle spawning, and this is just as easy. I implement this debug action here as an annotation. So say I want to increase the spawner speed, I can just write a method. So something like this, and I can do spawn delay minus because I want to go faster, and maybe I set it that it can minimum be. Okay, I need to make this floats because it's a float, so like this. And then I need to add the debug action. Debug action, I will put in the same category. So category, node name, and then, oops, that's not category, that's only the name. Increase speed, and it has no parameters. I can even add parameters here. So actually, let's do that. Debug change speed. Value like this, and then we can do this. Value. So increase speed is then minus 0.1f, and copy it, and I can say decrease speed is 0.f. There we go. So let's run it. Open my debug menu. I now have more buttons, increase, decrease. So if I keep hitting increase for this one, that was wrong. I should decrease. So let's just decrease. And you will see the top spawner is now spawning really, really fast. Right? So it's very easy to add buttons to the system. It's very easy to add visibility groups. And technically, you can modify the system as you want. I'm just doing this for my own game, and this is an example you can use. So let's have a quick look at the code. It's all inside this debug menu folder, and the main file you want to look at is this debug menu. If you go in Godot, you will see the scene. All you need to do in your project is to import this and add the debug menu as an auto load. Point it at the scene file, the tscn file, and put it as the first thing to load because you want it to detect everything else that's loading. Then if we go back to here, we can see how do I do this. I explained this in my quick tip video earlier. You can connect to the node added and node removed on the scene tree, and then you can detect the node added and node removed. And inside these methods, you can do stuff. So here I use reflection to look for annotations on every member and every method within it. So here I added a debug reflection util. This is because the first time if you do reflection directly on a big game, it will be really, really slow. This is why this util here is a cache, reflection cache. So every time you do a lookup, it will store it so that if you do it again, it will be really, really fast. This is why if you are including this debug menu in your game, you might notice that the first time you load your level or something, it will be really slow, but the second time it will be fast. And that is because of the reflection. You can circumvent this by doing the reflection calls before you load your level, like on your loading screen, and then filling your cache on your loading screen instead. Anyway, going back to this menu, you can find the source on my GitHub. It's linked below. When the node is added, it processes the member, processes the methods, then it processes the class itself with reflection, and then it checks which groups it's in, and if it's in a group that starts with a visibility group name, we add it to the list of visibility groups. There are then two other files you have the on-screen debug manager and interface. These are both taken from the MD framework, as you can see here. I won't really go into detail on these ones, but they are what's handling the on-screen debugging. Then you have the button menu, which is storing which actions are available, and so on. And something I didn't show you actually is that this also works if nodes are removed or added, because we are checking both on remove and add. So if I go to my moving icon here, I could add a on-screen debug, for instance, for the speed. Right, so it's very easy. Moving icons. Let's use a node name and speed, and then you need the name of, because you can only send constants. Ivory is fine. You can only set constants in annotation, so you can't set the color because color is not a constant, but you can set the name of the color, and inside this attribute here, I am actually looking up. I'm using reflection once again to find all the colors and looking them up when you and to see if it exists. Right, so let's look one more time here. So you can see the movement speed of all these icons are appearing here, and as soon as they get destroyed, it disappears from the list. You can do the same with the button menu. It also supports the same. You can have buttons being added and removed as stuff is disappearing from your game. It's a very flexible system, and it allows you to implement a debug menu that you don't really have to update so much. Because if you are doing it the way I've seen many people do it, where they write the code for each individual debug method to call some method or something, if you remove something, you would have to go to your debug menu and remove that from your debug menu. If you add something, you have to go and add it. It's a lot easier, at least in C#, to just use these annotations like this to add an action or something. If you're using GDScript, you can do something similar. You don't have annotations, but you could check. You could, for instance, add a method to your classes with debug actions, which returns a list of methods that can be called with names or something, and then you can add buttons for this. Because GDScript you can attempt, or you can check if a method exists on the node, and if it exists, you can call it. So I guess that's how I would do it in GDScript, from my knowledge. There might be better ways. Anyway, I hope this is useful to you. You can find the full source code for this thing in a link beneath this video. And feel free to use it for whatever you want, change it as you wish. Do whatever you want with it. I hope it's useful to you.